In this demo, we want to create support for editable proxy. So basically, we will have an interface which will be extendable by the contract of an object, and the interface will provide support to begin a transaction, commit it, or roll back it. Okay, so let's start by creating a new Java project. Let's call it demo. And in here, I will just create a dummy demo package. So the idea would be to be able to provide an interface with the appropriate methods for editing an object. So let me put it this way. When we have an object that's edited by the UI, and we set different properties on that object, we want to be able to revert the object to the initial state, or provide a clean copy at some point for other part of the application. So let's start by creating an interface and call it editable, this interface editable object of type M, which will be the model. So this interface will have to provide basic functionality for editing an object with transactions. And because we don't want to enforce the implementer of the interface to have specified the implementation for that for the methods in this contract, we will use the feature in Java 8 as default implementation. So I will have a default implementation for a method called begin transaction, and this will do nothing. Okay, and I will copy this in order to specify a new method. Okay, sorry for that. Commit transaction. Those will just be services provided by an editable object, and of course rollback transaction. Okay, we will extend this interface with a contract that will be the actual contract of the object. And because we defined here those methods, we will have the appropriate service for creating, committing, and rollbacking transactions. However, we would like to be able to cast or to adapt our model to an implementation of the editable object. Because we will use invocation proxy for that, invocation handler, we will have to create a handler on top of our model. So we will have here a method which will return the same model but as editable. And for the moment we will return map. We'll create an adapter that will be able to adapt the actual model that we have to an editable object. So the adapter will have to create a proxy on top of the model, and the proxy will respond to the invocations for begin, transaction, commit, and rollback. Okay, this is first step. Now let's go and create our support. Let's call it editable adapter, which will get a parameter type M. The editable adapter will have a method to adapt a model. Okay, so I will just have a static method in here. Sorry for that, public static. The method will have a parameter type called M, and it will return the same type by adapting the model to that type. So what we'll actually do, when we have a class that's extending or that's implementing an interface which is extending an editable object, this model won't be able to have implementations for transaction services. because we are not able to put state inside an interface, although we are able to have default implementations, we cannot use this editable object interface to actually implement the transaction services, because we cannot declare here a stack of transactions and have the state inside the interface. So we are forced to use an adapter pattern which will create a proxy that will be an invocation handler, and the proxy will be invoked each time we call a method on the model. Like for instance, when we call a transaction service, this will actually be dispatched to the proxy, and the proxy, since it's a class, will have a state and will be able to create a stack of transactions. So what we're gonna do here will be to collect all the interfaces that need to be implemented by the model and create a proxy to implement those interfaces. So this proxy will actually be our transaction manager. Let's start by collecting all the interfaces. Let's call this field interfaces. Sorry. Okay, I will create an array list of classes, and I will add in my array list all the interfaces that need to be implemented by calling arrays as list, and I will get from the model, from the class of the model, from the class of the model, get interfaces to collect them all. Besides that, my model should also implement the editable object. So I don't know if the editable object is already on the list of interfaces implemented by the model, so I'm not going to check that, but rather that I will add it to make sure this is available in my list. So the editable object should be also implemented by my proxy. Okay, I will create an editable adapter, of type M. Let's call it adapter. Okay, and I will pass the model in here. So I will have to create a constructor. I will have to create a constructor with that signature. I will continue implementing it later on. And I will create a proxy by calling the proxy supporting reflection to create a new proxy instance. As a class loader, I will use the same class loader as the model, get class loader. I will pass the list of interfaces cast to an array, and I will create in here an array for that. So the interfaces dot size should be the size of the array, and the adapter should be the invocation handler to handle this. Now it says that the adapter is not implementing invocation handler, so I will have to do it. And in here I will have to also add in unimplemented methods. In the end, I will return the cast to my model of the proxy. And I will also suppress warnings because this is the actual type that should be. Okay, that's quite simple. So up to this, I collect all the interfaces that need to be implemented, and I'm creating a proxy on top of that using an invocation handler to handle the actual call of the method. Now, let us focus on implementing the adapter. So what I would like to have would be to create a transaction manager which will hold a stack of transactions, and this should be using the model. So in here I will create a new transaction manager, and I will create an editable transaction manager of type M using the model. Okay, there is no class called like this. I will just create this class with a generic type M for the model, and in here I will also create a constructor for that class that gets a model as reference. And now I have to declare the field inside the transaction, the editable adapter. Okay, this is one step. Now, in here, when I will be invoked with a method, I will get a proxy as parameter. Here will be the name of the method, and of course the arguments. What I have to do here. So remember that each time we are invoked, we can get an invocation either of a method from the editable object interface or for the real object contract. So what I will do here is to check if the method belongs to the editable object, like for instance we are calling a transaction service, or if not, we will ask the actual object to do the job. First of all, remember that in here we said we are returning null, which is not okay. So when we are supposed to adapt the model to an editable object, we would like to use the editable adapter to adapt the model. That should be this object. Sorry for that. I will cast it to the model type. So basically, imagine that we will have an object that implements a contract, and the contract is extending the editable object contract. When we want to be able to have transaction support, we will ask to get an adapted object. So we will call as editable. As editable, we'll have to create a proxy. Otherwise, we won't be able to intercept unless we use AOP or other stuff. We won't be able to intercept the call to the methods of the real object. So we'll just say, please adapt me this object and provide me a proxy that will be able to intercept the calls to all the methods, either belonging to the contract of the object or belonging to the contract of the editable object service. So in here, now it's okay, we are returning what is expected, but in here, let us focus on implementing the invocation of the methods. So in my adapter, I would like to check first the declaring class of the method. So if the editable object, dot class, is the declaring class of the method, then we will have to invoke the proxy to handle that, with this exception. Okay, so what we'd like to have would be to as you can see here, when we ask the as editable, we will get an object, and the object is not a proxy. So we don't have to care about handling the call to the as editable method. Imagine that we will create an object that's in the end that's implementing an interface which is extending this interface, and we'll call as editable on that object. Because the object is not a proxy, we will get the actual invocation of this default method implemented in here. So we don't have to care about checking either or not the method that's invoked here is this one, because this won't happen. It's not possible to intercept this method as we are delivering the object. So we will only have to care about implementing those methods. This means that our proxy will have to provide these kind of implementations. Remember that we decided to do like this because we are not able to have state inside an interface. So we are not able to implement these methods here and collect all the transactions. So now we are in the position of getting the actual implementation of the method. What I would like to do is to have the same method with the same name and signature inside my transaction manager. And with this, I will just pass the call to the corresponding method of the transaction manager. So I will create a method that will call get homonymous method of, to get the method with the same name. And I will like to check for this method in my transaction class. I'm creating this method, okay, and after that I will just return the call of my method by invoking the method in passing as parameter the transaction manager and of course the arguments. Okay, and now otherwise, if the method does not belong to the editable object, then it's not a service that needs to be implemented by the transaction manager. So I will just get the model by using the transaction manager get model. I will have to create this method. Okay, and by the way, let us focus on storing the model. So I will need to have a field in here to store the model, and of course I will return this model. Okay, let us focus on the proxy. Okay, so now I have the model. I would like to search for the method with the same name to search for the method with the same name by calling get homonymous method inside the model class, and then this should in the end should be invoked. So I will just call method invoke. I will pass the model as context and the arguments. Okay, so this is the problem is that this should not be a class that extends editable transaction manager, but rather a generic class, and I will call it the type in which I'm searching for the method. Okay, let's implement this utility method. Basically, what it will have to do, it will get the method that should be public. I'm not checking about the accessibility of the method. The name of the method should be provided by the parameter method, and I will get the name, and the type should be method get parameter types. Okay, this can throw exceptions. I will just add throws declaration to the signature of the method. Okay, so in here I will return the result of invoking the method with the actual model. So that's about implementing the adapter. That's a simple proxy. What it does, it's checking if the method belongs to the editable object contract. If so, it will use the transaction manager to implement the same methods as in the contract, and if not, it will pass the call to the actual model. So each time we are setting something in the model will be called directly to set the value. So we are changing the object. We are not changing a copy of the object. We are doing so because we expect the model to have specific logics inside, and we don't know how to copy that logic. We can clone the value of the model, but this won't add the logic of setting the values, of setting the properties inside the model. So that's why we are not relying on setting the value of a copy, but rather we are calling directly the model to do the job, because the model knows its internal logics. Okay, let's move forward. So now we have to focus on implementing the editable transaction manager, because first of all, it doesn't have the appropriate methods, and the contract will break when we will try to invoke that method, because it won't be able to find the method with that signature. So first, let's copy those methods inside, in here. So we will have to provide those services with the same signature. Okay, next. First, this editable transaction manager will hold a stack of transactions. Let's create a stack here. So I will have to have a private field for that, which will be a stack. And I will create a class called editable transaction of type M. This is not created yet. Okay, those will be my transactions. So when I'm creating this, I will just create a stack. Now I have to create a class editable transaction with a generic type M. And in here, I will just instantiate my stack. I call it transactions. And I will just create a new stack of editable transactions over the type M. Okay, now what I'm supposed to do when I have to create a new transaction, that's not a problem. I will just say create a new editable transaction, put it on top of the stack. So that's quite easy. I will create an editable transaction of type M. Let's call it transaction. I will call the constructor to do that. Okay, of type M. Okay, and I will also pass the model, because it is expected that the transaction will need to know about the fields in the model. Now I'm creating a constructor for that in the editable transaction class. Once I have the transaction created, I will just use my transactions to push on top of the stack my transaction, and in the end I will have to return the transaction. So now I have to change the signature, because it is void and should not be void. It should be of type editable transaction. And I will also change the contract here to return something by returning none. Okay, so as you expect, when you create a transaction, okay, you should be storing the transaction inside the manager, but you should also get the reference to the transaction so that you will be able to have a save point, and up to that save point to call whatever you like, rollback to the state before the save point, or commit the changes of the save point. Okay, that's easy. Now let's see what committing a transaction means. Yeah, so when I'm committing a transaction, I will just check if there is a transaction on top of the state of the stack. So if my transaction dot size is greater than 0, and in the top of the stack I have something that's different than null, just to be sure that everything is okay, then I will ask the stack to pop the first element on top of it and commit that transaction. This method has to be created in the transaction class. Okay, but imagine that I began a transaction, I got a reference to a transaction object, and now I want to commit it. Of course, this is not available through the model, yeah, but why not? I should have the ability to do that. So now let's just creating a new method in here for committing and rollbacking a transaction. So let's say that we have a new commit method. I will just organize them to be together, and this will get a transaction parameter as well, and I will have to say the same for the rollback transaction. Okay, so now I'll have to add those two methods to my transaction manager. Sorry for that. Okay, so what I'm saying is that I will need to have a new public void method to commit the transaction, and of course this should be the previous method to roll back it, and of course another one to roll back, but from a transaction point. Okay, so now let's see how we commit a transaction. That's not a problem. When we commit a transaction, we would like to undo the changes and pop all the transactions on top of it. So first of all, let's check if the transaction is not null. And of course, let's check that the transaction belongs to the transaction list. So if transaction contains this transaction. If so, let's get the index of the transaction up to what we need to pop from the stack. So I will get the transactions index of my transaction. This should be greater than -1 because the stack already contains my value. And what I would like to do here would be to, as well as the size, it is greater or equals to index, I will get rid of the transactions on top of my transaction. So I will pop from the stack. Okay. And then I will, since I also popped my transaction with this object that was belonging to the list, to the stack, I'm asking the object to commit. Okay, now let's do the same implementation for the rollback. Basically, when I'd like to roll back a transaction, I will have to get the transaction on top of the stack, and I will roll back it. And I have to create this method here. Of course, when I would like to roll back up to a point in the stack, I will do the same mechanism to free the stack up to my object, and in the end roll back my transaction. Okay, that's just a simple service to do the job. Okay, but let's suppose that we need to do additional stuff here. Like for instance, we'd like to be able, with our editable object, to release all the transactions that has been created. So let's have a method here that will return a void, and it will be called release transactions. The method will do nothing in here, but as you can expect, it will be implemented by the manager. That's easy. We'll just use the transaction stack and we'll clear the stack. So each time a transaction service is called from this contract, either to create a new one, or to commit a transaction, or to roll back it, or to release the transactions, the actual call will go to the transaction manager, which can have state, which can hold a stack of transactions and use them accordingly. Okay, so now that we have the support to intercept calls to the editable object services, to the transaction services, and also to pass the call to the model for the rest of the methods, and we also have the support for storing a stack of transactions, we need to focus on implementing the actual transaction behavior. So what should do here? Remember that this transaction will be called to store the current values of the properties of the fields of my model. So we'd like to be able to have a list of fields discovered for my model at the time when the transaction is created. So let's create here a list of editable field. Let's call it fields. I'll have to create this class, and this will help me access a field from the model. When I'm creating a transaction, and by the way, this should not be public, I don't want to allow someone else to create a transaction, but rather let my package to do that, only my package. What we would like to have here, we'll create the list of fields to be an array list of fields. And we will have, basically the idea is the following. When we create a transaction, we need to store all the values that are set in my model. For that, I will use a wrapper, that's the editable field, but remember, what I have to do is not to store only the values that are set for the fields in my model, but also the inner values with infinite depth inside the model. Imagine that we have an object that's a container, and the container has inner fields, and those are complex objects that also have inner fields. So basically, when I'm creating a transaction, I will have to make a copy of all the objects in my model, so that if I use my model to get an inner field and then get an inner field of that inner field and set an inner field value of a field of that model, then I will have to create previously a copy of the model, so that when I want to roll back, this will be possible. So now what I have to do is create a queue of objects. Let's call it objects. I will instantiate a linked list of objects, and first what I'll do will be to add to the queue my model. Okay, now as long as I have objects in my queue, so as long as the size is greater than 0, first I will get the object from the head of the list, so I will just call my list to pull from the head. If the object is null, then I don't have to worry about this object anymore, because I don't have to store its value. Otherwise, I will get the list of the fields inside my object. So I'll call object get class and then get declared fields. I will iterate through all the fields. So for each field, let's call it field in the array list, in the array, sorry. I will add, sorry, in my fields I will add, sorry, not in this, but in this dot fields, which is in an array list, I will add a new editable field. And for the editable field, I will pass the field and the object. I will have to create a constructor with this signature. Okay, so this will be the field itself. But then now the problem is that I store the reference to the field and I need to visit the objects inside my field. So I will have to get the value of the field. So I'll have to have here value, okay, and I have to see if the field is accessible. So let's try to see if the field is accessible. If it's not accessible, then let's make the field accessible. And in the end, if it was not accessible, let's make it unaccessible again. In between, I would like to get the value of the field by calling the field get value, which is the get, with this object as parameter for the context, and I will retain the value here. Okay, now I will do a simple surround with try catch multi-block. If I have multiple exceptions, I will just let the value to be null, which is supposed to be already, but in case I have to do something in here. Okay, let's check if the value is not null. So for instance, I can say here continue. If the value is not null, then my object has actual value. If the value is an array, then I will have to iterate through all the instances of the array and put them to the queue, in the queue. So let's check if the value get class is array. If so, what I'd like to do is to get the length of the array, and I will use the array class for that from Java Reflect and call getLength, and the value will be my array. I know that's an array, I checked it before. And I will have to iterate through all the elements of the array up to the length, -1 of course, and store by adding in the queue the item with the corresponding index in my array. So the array will be the value and the I should be the index. So if it's an array, I will get the properties of each element in the array. Remember that I have to store the whole state of the object as a copy just for being able to do a rollback. Otherwise, let's check if the value it's an instance of a map of generic keys. And if so, I will have to store the image of the map. So I will just get the items of the map as an array, and for that I will cast my value to a map, a generic map, and from my map I will call values and to array. Now I have my items. What I would like to do is to visit each item in items and add it to my object queue. Just to visit each item and store its properties. But then, if it's a collection, and I will put my check in here, because it's naturally to come up after a static array. If the value is an instance of a collection, so if my value is an instance of collection, once again, collection, come on. Okay, if it's a value of a collection, then what I have to do is to get all the items of it in the same way, but now I am casting to a collection my value, and of course with this I will have to say to array, and I will have to iterate through all the objects. I will just copy this lines of code, and now I have my collection items added. Otherwise, if the value is not that, then I will just add to my object list the value, because it is not null and needs to be checked as it is. It's a single value. Okay, so this is what I'm doing when I'm creating an editable transaction, just checking and making a copy of all the objects in my model. Now when I'm committing, what I have to do here, normally I should visit all the editable fields that I stored previously, and I will ask the field to commit its value. When I roll back a transaction, I'll do the same to roll back its value, the value of each field. And of course I have to create this method as well. That's about all what I'm doing with the transaction. Actually, I'm just rolling back. Come on, I said roll back here, and it is okay. So the field has a rollback method. Okay. Let's move forward. What actually should be implemented with the field? So my field, my editable field, will have to store the value of the object. So first of all, it will have to store the reference to the field. Okay. So I'm creating this, and it will have to store the reference to the object as well. But then it will have to store the old value, and I will have a method to get the old value. This will be an object, and I will create this method as well. Okay, that's easy. Now for the get value, I will have to see if the field is accessible, and of course if it's not accessible, then I will have to make it accessible. So I will say field set accessible true. In the end, if it wasn't accessible, I will have to let it as it was. In between, I would like to get the value of the field by calling to get the value for this object context. Okay, this can, and in the end I will return the value. This can throw a bunch of exceptions. I will surround them with multi-catch block. If I have an exception though, I will create a new editable, I will throw a new editable exception, passing the localized message of the exception, and of course the exception as the cause. Now I create a class. This would have to have a default serial version, and I will override constructor from superclass, this one, to have the value stored. Now this method should throw an exception, and of course this one as well. And inside the transaction, this will also throws an exception. Of course, the manager will throw an exception each time it creates transaction. Now let's focus on the field again. Okay, so when I create a field, I get the value of the field that's currently set. But then let's focus on the other methods to commit a value and roll back the value. When I commit a value, what I'm saying is that the old value, the current value of the object, should be the actual value of the object. So I'm just getting the value. This should also throw an exception, and we need to change accordingly the colors. So this one will throw an exception, and if we do so, this one will might throws an exception as well, like in here. Okay, next. The next step will be to implement the rollback. The rollback will have to set the value of the field to be the old value that was stored before changing it. I don't have the method setValue, so I'll have to create it. But I will just move it a little bit up, just to group those together. Okay, so this was the value to be set. Now, how we can set the value of the field? I will copy the code for getting the value, which is a little bit similar. But instead of getting the value, I will just use my field to set its value for the current object to be the value. And I'm not returning this because I will just supposed to return null. And this should throw the exception as well, which means that rollback might throw an exception too. So I have to change here rollback that might throws the same exception as well. And again, two new methods to be updated, one here and another one here. And now I have my support for editing with transaction. Let's do a simple test for that, and I will create a simple iContact interface. The interface will extend the editable object contract of my contract. That means that I will be able to call the transaction support with objects of type iContract. Imagine that I have a contact which has a first name and a last name. So what I will do here would be to define methods for getting a first name. Let's do differently. Let's make it simple. I will create a class first. That will be my contact. And I will have two fields, one for the first name and of course the other for the last name. Okay, for those I will generate getters and setters, select all, and after that I will refactor my class and extract my interface with all the getters and setters, call it iContact. It's not iContact like seeing it, it's interface iContact. Okay, I have a lot of bunch commands in here. Let's clean them just to see the code. Okay, this is overriding the methods of iContact, and iContact has all those methods, which of course are public and abstract by default. So let's make it cleaner. This should extend the editable object of iContact. And now, imagine I have a simple program to check it. Let's call it program, should have a main. Okay. In here, I would like to create an object of type iContact. Let's call it contact, and I will instantiate it by creating a new contact. What I would like to do would be to get the support for transaction editing. This means that I will need to create a proxy by calling as editable. So now I don't have my contact instance, but rather I have a proxy that's embedding my contact. With this proxy, I can begin a transaction. Okay, because it is extending the editable object, I am able to say contact begin transaction. Let's try to set some values. I set the first name to be Julia. That's my name, okay? Right. Set the last name to be Ilie-Némedi. That's my surname. Now that I have set the object, let's make it simple. I will also override the toString in my class just to display it quicker. So my toString should be like, I would like to have a message format to format the first and last name of the object. So I will have first name and of course last name in here. Okay, so now after setting the values, I would like to output my object like my contact, and I will say that this is before rollback. Now I'm gonna do a rollback transaction, and now I will display the value of my object that's supposed to be before, that's after calling the rollback, but it's supposed to be before setting these fields. Now I'm setting the fields again, let's say with Gyula, that's my name in Hungarian, and also Nemedi, which is already a Hungarian name. But this time I know that the values are supposed to be set. I already checked this here. This time I am calling the commit transaction method. and I will output the value of the field after commit, the value of the object after commit. Contact. Okay. So now let's check it. I hope it will work. As you can see, before rollback, I managed to set the values of the field. After rollback, the object was restored, so the values should be null. Then I change it again, but this time when I'm committing the transaction, I have the values set. So as expected, which is normal, I have created my object and I have been able to modify it. So in conclusion, what we can do with simple framework like this one is to define, for instance, to define a contract that allows us to create transactions and work with them, commit those transactions, roll back those, or release in the end the context of the transactions. Then we can imagine that when we define an object, we define a contract that extends this support. Each time a method of the contract is invoked, the actual method on the implementer of the contract will be called. However, when we call a method from the transaction contract, from the editable object contract, we'll create the support in background to have to manage those transactions. So with this approach, we can design classes that implements contracts which extends the transactional support contract. So each time we want to have this transactional support, we create a proxy by calling an utility method to do that. And with this proxy, we can start save points, roll back them, or commit them depending on our needs. So basically, this approach is based on, first of all, on invocation handlers in Java Reflection, which allows us to intercept the call to the transaction methods, and also to intercept the real calls on the actual object. Those are not to be intercepted, but rather we want to let the object do its internal logics to set the value, to update it. However, we would like to be able to save the state of the object before changing it, and then being able either to commit or roll back. As you know, as you saw here, the commit is just storing the previous value, the current value of the object to be the previous value, so that when we will do a rollback, it will actually set the same values, like the values were accepted to be committed. Otherwise, if we want to roll back, then we have a save point with all the values of all the fields inside the object, which might be a complex tree of elements. And when we roll back, we ask each field to set its previous value as being the current value. So that's a simple editing support. Of course, we need to add support for making it thread safe, which we didn't care about it, but that's another topic.